a tiny green beetle that has killed millions of ash trees in southern Ontario, parts of Quebec, and the northeastern United States.
In 2009, a USDA scientist named Jian Duan knelt in a Russian forest full of wild tigers and started peeling bark off an ash tree with his bare hands. He was hunting something almost too small to see. 7 years later, New York began dumping tens of thousands of its descendants into state parks, on purpose, into forests where an invader from Asia was already killing trees by the million.
As the larvae feed, they damage some of those vessels that transport the fluids, and that eventually girdles the tree and causes the death of the tree.
It was either the smartest thing anyone had tried, or the second worst mistake in this entire story. Nobody knew which, and then the researchers went back out to count what was left. The stowaway. To understand why a federal scientist flies halfway around the world to peel bark off a Russian tree, go back 20 years to a wooden crate rolling off a boat near Detroit. Tucked inside the raw pallet wood, invisible to every inspector who waved it through, were the larvae of a small beetle from Northeast Asia. Nobody logged it, nobody photographed it. It is called the emerald ash borer, about ½ inch long, the size of a grain of cooked rice. A green so bright it almost looks decorative. Officials first pinned it down near Detroit in 2002, though evidence suggests it had been spreading since the late 1980s. And here is the thing that makes this whole story turn. Back home in Northeast Asia, this beetle is nobody. The ash there grew up alongside it over millions of years. They resist it, they tolerate it, and a cast of natural predators keeps its numbers pinned low. Duan, who has studied this insect for decades, puts it plainly. In its native range, the emerald ash borer does not kill trees the way it kills them here. North America was a different story, and the trees never saw it coming. The killing method. The ash here had no defenses loaded when it showed up. The adults do almost nothing, just nibbling leaves. The real killing happens under the bark. The females lay eggs in the crevices of the trunk, and when the larvae hatch, they tunnel into the living tissue beneath and start eating. That tissue is the whole game, because it is the tree's plumbing, the thin layer carrying water and nutrients from the roots to the crown. The larvae carve winding galleries through it and slowly strangle the tree from the inside out. Claire Rutledge, a scientist with the Connecticut Agricultural Experiment Station, described the arithmetic better than anyone. 1 larva is not a big deal. 20 larvae are not a big deal. 2,000 larvae kill the tree. And that is exactly what happens. A healthy ash goes from full and green to dead standing timber in 3 to 5 years. Hold that number because it is about to get multiplied by something enormous. A state's reckoning. New York holds around 900 million ash trees. That is close to 8% of every tree standing in the state, nearly 1 in 12. An ash is not an ornamental specimen behind glass in a botanical garden. It is a working tree. Baseball bats, hardwood flooring, furniture, tool handles, and the humble shipping pallet, which lands strangely when you remember how the beetle got here. White ash especially is a keystone species, meaning a whole web of birds, mammals, insects, and microorganisms leans on it for food and habitat. Pull the keystone from an arch and the structure does not lose 1 stone. It drops. The money is hard to picture. Across the United States, the beetle is estimated to cost local governments around $850 million a year in removal, replacement, and treatment, plus another $380 million in lost residential property value. Because a dead ash over your driveway is a hazard and a liability that shows up cold on an appraisal. And then the figure that tells you how thorough this insect really is. Of the ash trees it has attacked, more than 99% have died. Fewer than 1 in 1,000 survive. That is not a pest problem. That is an eraser dragged across the map. So, what did anyone actually do about it? When containment failed, for years, the answer was containment. Regulators drew quarantine lines across counties and whole states, restricting the movement of firewood and ash logs, hoping to buy time. The beetle was faster than the paperwork, jumping the maps in a bundle of firewood, a shipment of nursery stock. Injections could save 1 tree in a park or a front yard, but you cannot inject a forest. You cannot inject 900 million trees, and even if you could, you would do it again. Every couple of years, forever. By 2020, the United States Department of Agriculture reached a quiet, remarkable conclusion. the quarantine was not working. In December that year, it published a rule ending federal emerald ash borer quarantine activities altogether, effective January 2021. Read that plainly. The federal body in charge of stopping the spread officially admitted the spread could not be stopped and redirected everything towards something else entirely, which leaves one question hanging. If you cannot contain it and you cannot spray your way out of it, what on earth is left to try? If you are leaning in right now, do me a favor and subscribe. This channel goes deep on the strange, quiet ways American wildlife is clawing its way back from the edge, and there is a lot more where this came from. Because the answer had been growing quietly in a laboratory for more than a decade, and it takes us straight back to that cold forest and to the man crouched at the base of the tree. Into tiger country. The region is called Primorsky Krai. Duan went in twice, in 2009 and again in 2010, and it is not a gentle place to work. It is a vast wilderness of mixed hardwood and conifer forest, remote enough that it remains one of the last strongholds of the Siberian tiger. The idea driving the trip was one of the oldest in ecology. If the emerald ash borer is harmless across Asia because Asian predators keep it pinned down, maybe one of those predators could do the same job here. The most promising candidates were parasitic wasps that hunt the beetle relentlessly in its homeland. And Duan had one detail that made him certain the logic held. American ash trees, the exact same species dying by the millions back home, have been planted along the streets of Beijing. There, they survive. They grow into huge, healthy specimens because the local wasps hold the borers in check. The trees were never the weak link. The missing piece was the hunter. Now, he just had to find one. The hunters. Finding those hunters was painstaking work, something close to hide and seek against an insect the size of a mosquito. The beetle tucks its eggs under loose bark and into tiny crevices, so Duan went tree to tree, peeling, searching. And not for beetle eggs that had turned black. Because a blackened egg was a clue, it meant a wasp had found that egg first and quietly laid its own inside it. These wasps have no common English names, which tells you how far outside daily human life they sit. And to appreciate what they do, you have to watch how they hunt. A female lands on the trunk of an infested ash. Along her legs, she carries sensory organs delicate enough to detect a beetle larva chewing beneath solid, unbroken bark, a target she can neither see nor reach. Having found it, she deploys a long, needle-like structure and drills straight down through the wood into the tunnel below. Then she lays her eggs on or inside the larva, and within days her offspring hatch and eat it alive from the inside. It is a grim little drama playing out under the tree's surface. And it is, without exaggeration, the ash tree's best friend in this story. A single beetle larva can feed more than 100 developing wasps of one particular species. One grub, more than 100 wasps. That is the ratio that turns a modest hunter into a self-sustaining population in a hurry, which is exactly what made everyone nervous. Proving them safe. Because bringing a foreign insect into a new ecosystem sounds like precisely the decision that started this whole catastrophe in the first place. That instinct is a good one, and the scientists knew it better than anybody. So, before a single wasp entered an American forest, the beetle was not the only thing under a microscope. The wasps themselves were tested against 14 native beetle species inside secure quarantine laboratories, all to answer one question. Would they hunt only the emerald ash borer, or wander off and start harming native insects the way the beetle had harmed native trees? Duan has described the deep-set behavioral and ecological mechanisms that keep these wasps locked onto their prey. The results came back about as clean as anyone could have hoped. Of the 14 non-target beetles tested, only one was affected at all, and that one happened to be the gold-spotted oak borer, itself a serious invasive pest attacking oaks in California. The single off-target hit landed on another invader, and the timing was almost too neat to believe. Right as the old quarantine strategy was declared a failure, the wasp strategy cleared its final safety reviews. One door quietly closed, another opened at nearly the same moment. The Russian wasp. 4 species of wasp eventually earned federal approval as biocontrol agents. 3 hunt the beetle's larvae under the bark. 1, from China, hunts even earlier, destroying the beetle's eggs before they ever hatch. Another of the larvae hunters is that Chinese species whose single beetle host can raise more than 100 offspring. Excellent, with one catch. Its drill is short, so it works beautifully in young, thin-barked ash and cannot reach a thick, mature trunk at all. And then there is the standout, the one that made careful scientists start using cautious words like hope. It came out of Duan's Russian expedition, and it carries the traits you would design on purpose if you could. Its drill is long enough to reach larvae buried deep in big trees. It runs a full life cycle in about 30 days, so it fits 2 or even 3 generations into one warm season. And its broods skew heavily female, roughly 3 to every male, so the population compounds fast with every turn. Give this wasp a foothold, and it does not merely survive, it multiplies. Every wasp used in New York is reared in a specialized laboratory in Michigan, then shipped to the states running the program. Starting in 2016, scientists released them into carefully chosen sites across Connecticut, Massachusetts, and New York. Today, 38 New York counties hold at least one of the 4 approved species. And at state parks alone, the plan called for more than 50,000 wasps. Nationwide, since that first release in Michigan in 2007, the total has climbed past 8 million wasps across 30 states and the District of Columbia. 8 million wasps. And for years, nobody could tell you whether a single one had worked. Did it work? Because releasing an insect and having it establish itself are 2 wildly different things. A wasp shipped out of a Michigan lab and set loose in a New York forest has to pull off something extraordinary, alone. Find enough beetle larvae to feed on, survive a brutal northeastern winter, reproduce, and build a self-sustaining population on its own with no further help from anyone, ever. Plenty of biocontrol attempts have fizzled out at exactly this stage. This one, against the odds, did not. Duan's Russian wasp established a self-sustaining population within 3 years of its first release. Then, it did the thing the researchers were quietly hoping for, but could not promise anyone. It spread. The wasps pushed more than 8 miles out from their release points, hunting under their own power, colonizing fresh stands of infested ash no scientist had ever seeded. At those sites, they were parasitizing between 35 and 78% of the beetle larvae they came across. At 2 locations, the parasitism rate climbed from almost nothing to between 33 and 49% in 2 years, a nearly 30-fold increase inside that window. Then came the result that made headlines inside the field. A 5-year study led by a Department of Agriculture team found this single Siberian wasp could cut emerald ash borer populations by around 75% in mature ash forests. 3/4 of the beetle, quietly removed by an insect the size of a mosquito that almost nobody will ever see. Duan, who had poured a career into this exact problem, allowed himself one rare public moment of optimism. Finally, he said, "We see the light at the end of the tunnel," and then an honest telling has to slow down, because he is not the one overselling this. He never was. The honest limits. The wasps are not a rescue squad for the trees already dying. They will most likely never save the largest, oldest ash, the towering specimens usually riddled with larvae before anyone even notices something is wrong. What they do is knock the beetle's numbers down far enough that the smaller, younger ash get a real chance to grow up and reproduce. It is less a cure than a hard-won truce, one that keeps the species in the game long enough for the ending to matter. You can see both halves of that truce sitting next to each other in New York City. In 2014, researchers tagged 98 mature overstory ash in the city's natural areas and watched them for a decade. By 2024, 76 were dead, with only 15 new overstory ash grown up to replace them, a net loss of 61. And the decline lines up almost exactly with the beetle's arrival in the city in 2017. So, no, the wasps are not magic. Where the beetle reached first and hit hardest, the losses are already carved into the record. Not a clean victory, not a comfortable one, but the wasps were never meant to fight alone. And the second front is where this turns genuinely strange. The second front. Over in Ohio, researchers kept noticing something they could not explain. In forests where practically every ash had died, a stubborn handful were still standing, not clinging on by a thread, actually healthy. They earned a nickname among the scientists, lingering ash. And they were not simply the lucky ones who dodged the beetle. Some were actively killing emerald ash borer larvae on their own. mounting an internal defense the overwhelming majority of American ash could never manage. That cracked open a door nobody expected. A team led by the United States Forest Service began taking tiny twig samples from these survivors and breeding them, and the results moved faster than anyone dared predict. Selective breeding produced highly resistant ash within just 2 generations. And in a twist that almost sounds too convenient to be real, the offspring often turned out more resistant than the parents they came from. Researchers are now cultivating whole seed orchards of these resistant ash, quietly assembling the founding stock of a forest that might one day shrug the beetle off, the way the trees in Beijing already do. But that is a bet on a generation nobody alive has met. The wasps had to prove themselves now. The proof arrives. For a long stretch, the program ran on educated faith. The wasps were clearly establishing, but nobody had hard proof that any of it translated into healthier, living trees. That proof arrived in 2024. Researchers documented for the first time anywhere in the scientific literature a direct inverse relationship between how many beetle larvae the wasps were killing and how many ash trees were dying. More parasitism meant less mortality. Where the wasps worked hardest, the trees died least. It sounds like common sense laid out that way, but in science, common sense is worth little until the data confirms it. 15 years after a man knelt in a Russian forest peeling bark, the data finally did. And the forests back it up. At sites that had endured a full decade of infestation, healthy mature ash still remained at most of them in 2021, holding full canopies against every reasonable expectation, standing where the earliest models had predicted total collapse. Which does not mean everyone walks away happy. What remains? None of this erases the cost, and one piece of it sits outside any spreadsheet. Black ash, the beetle's single most preferred host across North America, is woven deep into the craft traditions of many Native American communities, whose generations of basket making depend directly on it. The projections remain sobering. Researchers estimate that across much of its native range, the great majority of black ash could be lost within the next decade or two. The wasps buy time. Whether they buy enough for the most vulnerable ash of all is a question only the next 20 years can answer. Step back, and the shape of this thing is strange to hold in your head. A beetle the size of a grain of rice rode into the country, hidden in a crate, and quietly killed hundreds of millions of trees. And the response, after every conventional defense had failed, was one man walking into a Siberian forest full of tigers to collect a wasp the size of a mosquito, testing it patiently against 14 of its relatives, and releasing it by the tens of thousands into American woods to hunt the beetle exactly the way it had for millions of years. As things stand right now in the forests of New York, that wasp is established. It is spreading under its own power, and where it works, fewer ash trees are dying. The old giants will keep falling a while yet. The young ones have a chance they did not have 10 years ago. And the largest insect against insect rescue effort in the history of North American forests is still being written, one short generation of wasps at a time. So, tell me where you land. Was releasing millions of foreign wasps into American forests a stroke of genius, or a gamble we just got lucky on? Drop it in. Comments and subscribe before you go, because the next story is already coming.